So in last lecture, we have seen the program execution process. So in short, I had told in last lecture, and the diagram I have changed little bit here. So what is the process? So normally when we type any program, so we use any editor. So when we use editor, so that editor we type that program using the any natural language like English or something, right? So that reason is that human can understand only English language. But if you consider that computer, so computer doesn't understand that English language. So computer understand only the machine language. Machine language means that is a binary language. So that binary is having only 0 1 0 1 0 1. Like so only computer understand that language. So that's why we need to follow some processes. If you are able to write your program in binary language, then computer can understand directly that language. But normally we write that program in the English language, right? So that program we give as a input you can consider. So first step of that conversion from the English language to binary language is the translator. So yesterday I just told you again about the translators. So these are the three translators. These are the system programs, the assembler, compiler, or interpreter we can say. So compiler and interpreters are for the high level language. But when we consider that assembler, so that assembler is for the assembly language. You just consider this part only. Otherwise, that aim of these three translator is to convert your source code to object program or object code. That is the thing, right? Here, the translator translates that source program to object program. Here you can see, I just maximize this. So translate that source program to object program. And yesterday again I had told about this linker. I'll just tell you in detail about the linker. First I'll just complete this part and then we'll go for the linker and loader, right? So here then that linker will create that executable file and that will be load that file into memory using the loader. So this is a process I think, right? So first we'll see about this the translator, then we'll go for the linker and loader, right? So compiler and the assembler are same. Only that input for assembler is the assembly language and for compiler is the high level language like the C, C++, Java, Python, something. Right? So that you just consider. So I'll just explain that compiler. You just relate that compiler with assembler. Uh, see, first we'll see the compiler and interpreter. I'll just tell you in short. Suppose here compiler and this side you consider the interpreter. Okay. So here, suppose this is a program, like this program is having number of lines and that program name is suppose abc dot c or any. And now here the program file that is the xyz.py, suppose this is a Python. We know the Python uses that interpreter and compiler used by the C programming, Java programming, or the C++ programming. Now what that the compiler do, so that main aim of the compiler is what to translate the source program written in any the high level language into machine language, right? It means suppose that printf statement is there, this printf statement. So we need to convert this printf statement in the binary form, right? So this is our aim because this part is understandable by the computer and this part human can understand. Now here also that aim is same. Suppose print, sorry, simply print we use. Print, and this will be converted to binary format. So the aim of the compiler and interpreter is same. Only the difference is what in compiler. So whatever the machine code that is executed the many times, and when we convert that uh, program to the object file, so this compiler will consider the complete file or complete program. So if you have idea about the C programming, so what we do in C programming, we first compile our program, right? So when we compile, so that whole program will be compiled, and if any error is there, then that program gets false and it shows that error is there. So unless and until your program is error free, it cannot create that object file or it cannot run. So that is the reason here that compiler compiles your complete program at a time. And when we consider the interpreter, so interpreter convert, I'll write here, convert to object code line by line, right? And if you consider this one here, complete program can be converted to object file or object code we can say, right? So this is the main difference. So this compiler complete all lines, whatever the lines are there into that file. So that will compile first, check first, and then it convert to the object file. But here interpreter uh, first complete, suppose this line, that convert it, then this line, then convert it, then this line convert it, then this line convert it, right? But here all lines it will consider. This is the one difference. Second difference is what? Once we compile your program using compiler, so it creates, like suppose that exe is created. So we can execute that exe later at any number of time. So whenever we just create this exe, so in this case, so if you don't have that program file, then again that file exe will be executed number of time. So for just running of that exe, this original file, this one is not required. Just you just keep in your mind. But here, if you see, as we are just reading this one and we are converting suppose into the object file, then again this, again convert, again this, again convert. So it means to create object file, that original file is required. So here original file as required, right? Then second thing is, once we create here in the compiler, once we create that the exe, so this will increase the speed. We can say here, because once we compile that program, then second time only we need to run that exe, so it will increase the speed. But when we consider the interpreter, it is time consuming. Time consuming. Getting this one? So this is only just difference between the compiler and the interpreter. So same thing when we consider the assembler here. So the things are same, whatever the things we have seen. Only in this case, in the compiler, that file would be like here. or that language we consider is high level language, right? And here we can consider that original file in assembly language, right? So this is the difference. So the rest things are same. So have you understood this? So what is difference between compiler and interpreter? So compiler is what? Compiler is a program that translates a source program which is written in any high level language like C, CPP, Java, and that convert to the machine code. Machine code is what? This is the binary code. You can see here. So binary code. And that generated machine code can be later executed many times against the different data each time. Means what? If you see this exe, right? So what I said, so without this original program, this exe can be executed number of times. So suppose this program is the addition of two numbers, so that input required for addition of two numbers a and b. So when you run first time this program, so you can give that input like 10, 20. When you execute second time, so 30, 40. When you execute third time, so 100, 200 something. It means for different data, you can execute that exe file number of times, right? And this compiler is a tool which is having ability to read source code, which is written in the high level language. So like C or CPP. And whatever is the output of this will be easily readable by the computer. Getting this? Now, why it is required? Why that compiler is required? So that reason is whatever is the computer that cannot understand that English language or any other language other than the binary language or machine language, you can say. So that's why we need to convert that the program written in C or CPP or any in English language to the machine language. And the human can understand only that English language. That's why we can use any editor to type this one. Getting this? So this is, I think, assembler or compiler and interpreter. Now, what is the advantage of interpreter? We have seen from this. Advantage what? It is executed line by line. As I said here, so first line, second line, third line, fourth line can be executed. Now consider here in this case, in this line, suppose that error is there. Getting? So what happens in this interpreter? So whatever are the previous line, that these lines will get executed, these will provide the output, and only when that interpreter comes to this line, so this will say error. But this case will not be there in the compiler, because in compiler, so it first compiled whole program and then it provides the error. I think you might know that Python program. So in Python programming, if suppose first two statements are correct and third statement is having some error, so it shows whatever is the output of first two lines. So that it will show, and then it will show key that there is an error in the third line. Getting this? And what would be the drawbacks of this? So it is time consuming, we can say. As I said, it is time consuming. This is the drawback of this one. Getting this? So the best example for this is, I think, Python. This is the example we can say. Getting this? Have understood this? Assembler or compiler and interpreter? Yes. Okay, then we'll just move towards our the slides. 1 minute. Okay. Then we'll see. Through we have seen this. Now the compiler or assembler. You can see here, it's the simple diagram I have just given here. Suppose it's a C program or CPP or any program we can consider here. And using compiler, we can convert that file, that C file to the object file. And that C program, whatever is written, that is a human readable format. And this is a computer understandable format. So what is a compiler? Then compiler is a program that translates a source program written in some high level language programming such as Java or C or CPP, that to convert to machine language or machine code, right? So as I said, it is used to translate or convert the high level language program to machine level language program. The generated machine code can be later executed many times against different data each time. Already I just told you in this, once we create the exe, we can run that exe number of times for the different data. And that example I had considered that is the addition of two numbers. Now, compiler is a tool which has the ability to read the source code and translate it to object code. So that is obvious. Now, the output of the compiled code is referred to as object code, or sometimes it is called as object module. And as I said in last lecture, I think it is to be noted that this object file or object module is not related to your the CPP or Java object, right? Here I think it is related to OOPS, means object oriented programming, right? Now, why do we need compiler to execute the program? So because because computer can't understand the source code directly, because that we write in the English or any like language, assembly language. It will understand only object level code. It means that is a machine code, that is a binary code. So that computer only understand the object level code, or we can say machine code. Source code are human readable format, but the system codes cannot understand it. Right? So the compiler is intermediate between human readable format and machine readable format. So this is about, I think, the compiler. If you are having any doubt with this, you can ask me, please. And now same thing for the interpreter. So if you see this interpreter, so again same high level language, the interpreter and machine language are object file, that is same. So what this will do, so it converts high level language to machine level language. This is the thing, because same compiler is again convert high level language to machine level language. Only in compiler, the whole file first considered, and here that one line first considered, and second line and third line. It means read line by line, right? And if an error is found on any line, the execution stops till it is corrected. Getting this? So the examples are like the languages which are using the interpreter. So Python, Ruby, Perl, PHP, and MATLAB. So these are the languages which uses the interpreter. And as I said here, the advantage is what? It is executed line by line, which helps user to find error easily, because the line by line it reads, so that it becomes very easy to find out the error. And disadvantage already I just told, it takes more time to execute successfully than compiler, right? So this is the interpreter. So here the same thing I have written here, not necessary to again, I'll just read it. All high level languages need to be converted to machine code so that computer can understand the program after taking the required input. So that same thing, same meaning. Now second is the software by which the conversion of high level instruction is performed line by line to machine level language. Now here this word is important, line by line. If you miss this word, then it becomes the compiler, right? So line by line to machine language other than compiler and assembler is known as interpreter. And if an error is found on any line, the execution stops till it is corrected. So this process of correcting error is easier as it gives line by line error, but the program takes more time to execute successfully. So already I just explained these points, right? And these are the interpreters. So I have just listed There's some interpreters for the Python, for Ruby, for Java, and for this Kotlin. So these are the languages, and these are the interpreters. Right? Any doubt in the comparer and interpreter? Okay. Now can I move towards the linker? Okay. See, this is the process. I think yesterday the most of the peoples was having some doubt about the linker. So today I'll just explain you in detail about this linker so that you will understand what that linker is and what is the role of this linker. So see, in that uh, program process, the diagram also given, and here again that the diagram is little bit modified. Okay. Suppose the translator translate that code, high level language code, to the object code. Suppose this is object one and this is object two, right? So these two are the object files, and these are having some the references. This object one and object two. So what is the aim of this linker? So whatever these two files need to combine into a single file. Here you can see, and that file will have the references of this object one and object two. We can see here, right? Only this part is there, this one for the linker. And these are of two types, this static linking and dynamic linking. I'll just again explain you a little bit with this. Just a minute. Now we'll just see linker. See, suppose one program is written here, that program will consider like include, right? This one void main, and suppose I'm using here one function that is sqrt4, right? So this is your the original program. What is our aim? We need to convert this to the object file. Now here that object file would be, say, I'll just use the random numbers. Right? So suppose this is the object file. Object file of which the code. So this object file is of include. Because that reason is whatever is this one, this is the inbuilt function. Right? So that sqrt4, this is an inbuilt function. It means whatever are the libraries required to this sqrt, these already are there into your compiler, right? So suppose here that library code is here, suppose for the sqrt function, right? Suppose this is having, getting this. So this is the object file of this sqrt function. Now, what is our aim? Our aim is what? See, here we have two different things. One is whatever is the include str.in and void main something is written. this one, and second one is SQRT function. But this is the inbuilt function, or we can say library. So this is here, you can see this one, right? Now the main role of linker is coming here. So suppose this, we are using the linker, right? This is a linker. So what that the linker is doing, this object file of the REST part and this object file of SQRT function, these two files are combining into one. So here you can see, suppose whatever is the this file, this one, this is 1011011101100 okay. So this I just this one, and whatever is this object file, again we need to include here, and this is what this the binary is 11004 times 1, right? So this object file of, wait a minute, I'll just simply write this SQRT, right? This one. So what this compiler did, so it combined this object file and this object file of the this one, that is include, and second object file of SQRT. So this has been combined over here, and then using, or you can say that this will be created the file. This is executable file. You can understand this is actual executable file. This is not the executable file, or again, this is not the executable file for this program. You just keep in your mind, this is the executable file, this one, for the original program, because this is a partial file and that SQRT file is also partial. So these two files have been combined by the linker, and then next, whatever is the function of the loader that comes here, loader comes. And what that loader will do here, this loader will see this file is suppose saved, this one saved on hard disk, right? So this loader will take or fetch that file from the hard disk, and it will send this file for the execution to the main memory. So this is main memory. So whatever is this file, I'll say this file as a suppose, right? So this is a file. And once we know, once that file is coming into the main memory, then we can execute, or this will send to the processor for the execution. So this is the for execution, right? So this is, I think, the function of the linker. Have understood this? So this is the original file. This one is the original file. This is the file. This is the object file for this is object file for this the previous part, and this file is for SQRT. Getting this? Now here uh, we have the 2 points we have seen. The first is static linker or linking, and second one is dynamic linking. So what is the meaning of static linking and dynamic linking? So that meaning of static is whatever things we consider at compile time. And in dynamic, whatever things we consider, these things we consider at runtime. So that is the difference between static and dynamic. Now we'll just talk about the static linking and dynamic linking. If you see here, so what we are doing here, whatever the example I just explained this is coming under, this example is coming under static linking. So I'll just tell you why this is coming under static linking. See, this is the object file for the include, and this is the object file for the sqrt. And what the static linker is doing, whatever is this object file for the sqrt, so that we are bringing complete file into this one executable file. So what is the problem with this? Suppose in future this file has been modified. Getting? Suppose this file is modified, but we have created the exe, and after just creation of this exe, this file has been modified, but we have the old file here. You can see here this code is of old file. So this is the main problem, because if you want this original file, whatever the updated file again here into this, so we need to compile that program again. Whatever is the exe we have created, that becomes the, or that we can say expire, and we need to recompile our program, this original program, and then again this updated file we need to bring here, and then we can create exe and load it, send to the memory, and then we can execute. So this is the main problem of the static linking, because we are bringing complete the exe of this sqrt into this, and if suppose this original exe is getting modified, then this exe is not having the use. So this is the one thing about the static linking. So what the dynamic linking would be? In dynamic linking, so first time, suppose whenever whoever is this using this sqrt function, so that whatever the code of this would be there into the memory here, like 11001111. So this is of sqrt, right? And suppose this is having some address, suppose 1000 or 10,000, right? Whatever is the base address of this, the file, this is the 10,000. Right? Now, what that dynamic linker do? So instead of bringing this code again, complete code into this executable file, simply this brings, 1 minute. Simply this will bring this base address of this one. It means if suppose this file is getting changed, so that address will be there. So it is just referring that address. With that address, it will go there and it will read that file. So this is the use, or this is the beauty of this dynamic linking. Have understood this? I think you might understood. If you are having any doubt, you can ask me. Right? This is a the
Sorry,
linker. Yes.
can you please explain once again? Dynamic
Which part
linking.
or okay, dynamic linking.
Dynamic linking.
See, yes. I'll explain. Right. See, in static linking, I think you have understood the static linking. Yes.
Yes, sir.
Okay. Now see what we are
Yes,
doing in
sir.
static linking, dynamic linking. So in static linking, we are bringing this complete the code into this executable file, right? But in dynamic linking, we are not bringing this complete code into this executable file. Instead of that, we are simply referring the address of that object file of that sqrt, suppose. So this is the address. Suppose the 1000 is the address of this sqrt object file. So simply we are referring that address. So suppose in future the original file is getting updated. So then again in that case, we don't have any issue in this executable file because simply it is referring the address of base address of that executable file. Have you understood?
Yes, sir.
Hello? Okay. Again, I'll just
Yes,
explain with the
sir.
PPT. Okay, okay. Thank you. 1 minute. Huh? Again, I'll just explain that same thing. I think you might understood this, the object file 1, object file 2 and something, why these files will be created. So now only I have just shown the files here for the simplicity, but there are many object files are there. Right? If your program is bigger one, then in that case, many object files would be there. Now, explain the static linking and dynamic linking. With this, I'll just explain. The same example I have just written over here. Suppose this is our program, right? I am just explaining, suppose the static linking. Huh? Suppose we have this program, this is the C program, right? Now, first step is what? We need to convert it to the object file. So this is the object file, suppose, right? And it is calling to the sqrt function. This is converted the object file for this include stdio.h, and now we are calling to the sqrt function. Now suppose this is the sqrt function. This is the library because this sqrt is an inbuilt function, and the machine code for that sqrt is this one. You can see here, right? Now after this, that role of that linker will come here. Now you can see this is the linker. It first brought this file into the resultant file. So whatever is this code is there. Now we need to bring this code into again this file. So you can see here, this code is brought here, and then this will be created as a executable file. Getting this? So code here I have written code of sqrt function is included in final executable file. So whatever is this code, that will be included into the final executable file, right? And once we create this executable file, so this file we can run any number of times with different data. And after just creation of this exe file or executable file, the next part of that loader will come. So that loader will load this executable file to the main memory. And then in main memory, once we send that file, so that will be executed. So you can see here, what is the problem with the static linking? I'll just explain it. Already I have explained, but with this diagram again I'll explain. Suppose this is a library function or executable file for the any library function. Here we consider the sqrt. This is the object file of the program. We converted this to the exe here. Now once you create this exe, you can see here, once you create that exe, suppose on my laptop I have created the exe, so simply that exe I can copy and I can paste on any other laptop or in any other computer, and when I just copy paste there, so I can directly execute that executable file. So now here what this represent, this person is the different person who is executing simply this executable file. Getting? So once he execute that file, if suppose this original library of that sqrt is not getting modified, so this will get the result, right? This one. But problem is when if suppose this original exe or that library of that sqrt is getting changed, then there will be the problem for this person. Getting? So here they have just shown the steps also. Exe file generated. First step, user take exe file, this one. Then some changes made in suppose in this original file. And if suppose you want the correct output, again compilation needed so that exe file include updated sqrt function. This include means that the hash include stdio.h. Huh? So again, you just read this. Again, compilation needed. If suppose that original exe of sqrt function is getting modified, then again this compilation needed, so that exe file, that is exe file of include updated sqrt function. So whatever is the sqrt function updated, so that will be getting reflected into the final one. Have understood this? So this is, we can say, drawback also. So because every time after modification, we need to compile it, recompile it. So this, whatever is the drawback of this one, that is just removed in the dynamic linker. We can see here. With this example again, you will understand. The rest part is same. Only you need to understand this executable file. So in the previous diagram, you can see here whatever is this binary code that we copied here into this executable file. You can see here. But if you consider this dynamic linker, so in this, what we did, suppose that sqrt function is there into the memory, right? And that address, base address of that is this one. Now what we are doing here, so this is the binary format or machine code of this file, excluding this sqrt, and whatever is this part, simply we are referring the address of this sqrt library function. You can just say this, only we have written this over here. It means if suppose this function is getting updated, this function, so we don't have any problem because we are simply referring that one. When we execute this, so only we refer this. So if it is modified or updated, this will be considered here, right? So this is nothing but the dynamic linking or linker. Have you understood this? Yeah. Okay. Now the next part is very simple. Already you understood that part. That is a loader. Sorry. The examples again I have just given static linker. In Windows, whatever are the libraries which have the extension like .lib, right? So these are the static libraries, and in Linux, whichever are the files with extension .a, these are the archive files. These are the static linkers file, and in dynamic linker, so for the Windows, the extension is .dll. So it means these are the dynamic link libraries, and in Linux, that extension is .so, shared object. So these are for the Linux, right? Now the loader is part here. Suppose we have created that exe file here. This is a exe file which is created by this linker. Now the aim of this loader is what? Simply to load this executable file in memory for the execution. So this is only the aim of this loader, right? So here I have written here. This is loader. Huh? I think I don't know whether you are able to see that heading or not. Okay. 1 minute. Okay. Now see, the definition of the loader is what? In computer systems, a loader is the part of an operating system that is responsible for loading programs and libraries, not simply programmer. So we have seen example that in that example, that original program is different thing, and libraries, that is sqrt library, that is a different one. So that loader aim is what? To load both the program as well as libraries into the main memory. So it is responsible for initiating the execution process, because when this loader brings this file, executable file, to the main memory, so that execution gets initiated. You understood this? So this is a loader. So process or functions of loader, the few functions of the loader are like the allocation, loading, relocation, and linking. So allocation is what? That space for program is allocated in the main memory by calculating the size of the program. So whatever is the size of your original program, so that will be calculated, and that kind of memory has been reserved. Loading, that brings the object program in to the memory for execution. Memory means primary memory, right? Relocation, when program is loaded from secondary memory to the primary memory, so its address gets changed. So this address will be handled by the loader, right? And linking, already we know that linking means which combines two or more separate object programs and supplies the necessary information. So these are the four functions of that loader, we can say: allocation, loading, reallocation, and linking. I think you might understood. So we'll see the difference between the linker and loader, right? So they already we just discussed all these points. Only we just compare here. Linker means, what is the main function of linker? Main function of linker is to generate a executable file. We have seen. So one, the program object file and SQRT, that is library object file, these two will be combined into the executable file. So this is the main function of the linker, is to generate the executable file. So what is the function of loader then? To load executable file into memory. Because once that executable file is created, then next function of that loader is to load that file to the main memory. Now linker, here you can see the linker takes input of an object code generated by compiler or assembler. It means this is talking about the input. So input is whatever the object file that has been created by the compiler or assembler. So that will be taken as an input. But in the loader takes input of executable file generated by the linker. That is obvious because it is loading that executable file into the memory. Now third, the difference is what? Linking can be defined as a process of combining various pieces of codes and source code to obtain a executable file. So that is the same thing. It is just combining the multiple object files. Some are the program object files and some are the library object files, right? So in loader, loading can be defined as a process of loading executable code into main memory for further execution. This is the loader. Now, last one is another use of linker is to combine all object file, right? And here it helps in allocating the address to executable code or that file. So these are the four differences, the linker and loader. So have understood this? So these are the system programs which are there in your syllabus also. So we have seen these, the assembler, compiler, interpreter, and loader. These are the system programs which we have seen, right? So this is the for this today's lecture. If any doubt, you can ask me, please, right? If you are having any doubt, please ask me. I'll stop sharing of my screen.